Open your banking app. One morning, the balance is $50 higher than expected. Nice. Now imagine it is $50 lower. Same number, same distance from yesterday. But for many people, those two changes do not feel remotely equal. A gain can help. An equal loss can matter more. That asymmetry is the central idea behind loss aversion. But the useful version is more precise than the internet slogan that losing simply feels twice as bad. Loss aversion describes sensitivity to losses compared with equivalent gains. The comparison is crucial. A $100 loss is not being compared with nothing. It is being compared with a $100 gain around the same reference point. In 1979, researchers Daniel Kahneman and Amos Tversky introduced prospect theory, a model of how people evaluate risky choices. Their key move was to stop treating value as a simple function of total wealth. Suppose Maya has $10,000. Classical descriptions might focus on the final total. Prospect theory asks a different question. Did the outcome feel like a gain or a loss from the point Maya was using as normal? That normal level is the reference point. Outcomes above it are encoded as gains. Outcomes below it are encoded as losses. The reference point is the hinge. Without it, the words gain and loss are incomplete. The reference point is often the status quo, but it can also reflect an expectation, a recent balance, a goal, or the outcome you were promised. Change the reference point, and the same final result can change psychological category. Maya expects a 5% raise. She receives 2%. Her salary increased, so compared with last year she gained. Compared with the raise she expected, she is 3 points below the reference. The same outcome now contains a perceived loss. Prospect theory represents this with a value function. The horizontal axis shows gains and losses relative to the reference point. The vertical axis is not money. It represents the decision value assigned to each change. On the gain side, the curve usually rises but gradually flattens. The first $100 may create a larger change in value than moving from $900 to $1,000. This is called diminishing sensitivity. The loss side also becomes less sensitive farther from zero, but it bends in the opposite direction. Most importantly for this story, the curve is typically steeper immediately below the reference point than immediately above it. Steeper means the move from 0 to -50 creates a larger change in decision value than the move from 0 to +50. It does not mean scientists found a universal meter that measures literal emotional pain. Now consider a coin flip. Heads, you gain $100. Tails, you lose $100. The expected money change is 0. Yet many people reject this gamble because the possible loss carries more weight than the matching gain. You may have heard that losses feel exactly twice as strong as gains. Treat that as a rough illustration, not a law. Estimated asymmetry changes with the stakes, the task, the person, and how the choice is measured. Here is the mistake that breaks many explanations. Loss aversion is not the same thing as risk aversion. Loss aversion compares the value of gains and losses. Risk aversion describes a preference for a safer option over a risky one. Imagine choosing between a guaranteed gain of $50 and a 50-50 chance of gaining $100 or gaining nothing. Both have the same expected money value. Many people prefer the sure game. That is risk aversion in the gain domain. Now choose between a guaranteed loss of $50 and a 50-50 chance of losing $100 or losing nothing. Again, the expected money value matches. Yet people can prefer the gamble, hoping to escape the loss entirely. That is risk-seeking in the loss domain. So people do not carry one permanent risk setting. Choices can shift between caution and risk-seeking, depending on whether outcomes are framed as gains or losses, and on how probabilities are perceived. Humans hate risk is too crude. Loss aversion is only one component of prospect theory. The shape of the value curve contributes another. Probability weighting contributes another. Keeping those pieces separate prevents one catchy phrase from pretending to explain every choice involving uncertainty. A choice can also be reframed without changing its final outcomes. A 90% survival rate and a 10% mortality rate describe the same aggregate result, but they place attention on opposite sides of a psychological frame. Feeling a loss strongly is not automatically irrational. Losing rent money can create real consequences that an equal gain does not erase. Constraints, obligations, and safety margins matter. The bias story begins only after those practical differences are considered. Loss aversion may contribute to holding the status quo or valuing something more after ownership, but those patterns have other possible causes too. Do not rename every refusal to sell, switch, cancel, or walk away as loss aversion. To use the idea, begin with one question: what is the hidden zero? Is it yesterday's balance, the price you paid, the outcome you expected, or a target someone gave you? Name the reference before judging the reaction. Next, remove the gain and loss language for a moment. Write down the actual final states. How much money, time, or safety remains under each option. This exposes cases where a dramatic loss frame hides two nearly identical outcomes. Then, run a mirror test. If losing 50 changes your choice, ask whether gaining 50 in the opposite direction would change it equally. A large mismatch does not prove an error, but it reveals where loss weighting may be steering you. For repeated decisions, set thresholds in advance. Decide when you will cancel, sell, switch, or stop before the current option becomes your psychological reference. A pre-written rule cannot remove emotion, but it can stop the reference point from silently rewriting the decision. Return to Maya. The 2% raise is a gain relative to last year and a loss relative to her expectation. Both descriptions are true. The better decision comes from knowing which reference is emotionally active and which comparison is practically relevant. Losses can loom larger than equal gains, but only relative to a reference point. So when a loss seems to dominate your choice, find the hidden zero, compare the final states, and ask whether the asymmetry reflects real consequences or psychological weighting.